like to introduce my good friend Tyler Smith. He's an engineer. He works with B Consultants. He's a building envelope consultant, and he solves complex problems encountered in building envelopes. So, welcome, Tyler. Thank you so much for being here, man.
Yeah, thanks, Scott. Yeah, I'm really glad to be here. I'm really passionate about building science and helping people, and it's really cool to see you guys all here with thriving interest and learning more about how to do buildings in a great way and embark on your own journeys of doing your own designs and maybe your own buildings and stuff. So I've learned a lot of complex things over the years in engineering, and I could, of course, would enjoy to speak for hours about really technical aspects of building envelopes and whatnot, but I'm going to try to keep it basic for you guys. I just want to, my goal here is to get you guys some just really solid and pragmatic information that can be helpful to you in your journey here and kind of keep it inspiring. My name's Tyler Smith. I'm a licensed and practicing engineer. I live in Portland, Oregon, and I've been a building envelope specialist here for 15 years. I grew up outside of Baltimore, Maryland on the East Coast, and then I was trained in architectural engineering at Penn State University. So I lived in Middle Pennsylvania for 5 years there, and that's where I learned a lot of what I think of as the complex basics. Like they're basics, but it's kind of complex. The different technical aspects of building construction and design. So I learned structural engineering. I learned electrical design in buildings and electrical construction, HVAC and mechanical design and ventilation and everything. And construction management was actually my focus on my degree. And then we learned a lot of the basics of architecture too, and the history of architecture. We did some design studio, figure sketching, all kinds of stuff, which was really valuable experience for me. And I was also involved in college in a lot of sustainability groups and stuff. I was in a group called the Engineers for a Sustainable World, and we did projects we designed anaerobic digesters that were for a farm in Jamaica that they could mix chicken and cow waste basically and generate a biogas that had methane in it and then burn that in a generator to help basically offset their electrical costs and stuff. So I've kind of been involved with sustainability and energy design since the beginning of my career, if you will. And yeah, I'm just really excited to be here talking to you guys about natural building techniques and stuff. So 2008, I graduated from Penn State and I got a job doing building envelope consulting in Portland. So I moved to the West Coast. It's kind of a big move. And I said, if it's lame, I'll try something else. And now I'm still here 15 years later. I can report that it's not lame. I've met a lot of good people along the way, like Scott, who I met probably, I think a year after I started working, actually. I think it was 2009 or so. We ended up being roommates and got to know each other real well and playing music and talking about buildings. And it's been really exciting to follow Scott's journey on natural building over the past 14 years, and I was really glad that he asked me to be a part of this. But yeah, so 2008, I came to Portland. I started doing envelope consulting, and that basically what that entailed was helping to design building enclosures so that they don't leak water, mostly, I'll say, because in the Northwest we have a ton of rain, and not necessarily a ton of rain, but enough rain frequently enough that if your building's leaking water, you're very highly likely you're going to get mold and problems and lawsuits and stuff like that when you're dealing with big commercial buildings. So I learned every which thing there is to know about keeping water out of buildings. I tore buildings apart that had leaked and figured out why they were leaking, did spray water testing on buildings to see why they're leaking, and then recommending the proper repair. So I've seen it all. I've seen 4-story wood frame buildings where they pull all of the siding off and you can look and see oh yeah, there's rot spots under the corners of every window, and I basically got a really good comprehensive understanding there. And part of my job was I got to do rope access inspections. So that's what this photo is. You can see that person hanging on the string on the right-hand side of the photo. That is me. So I got some other photos of that for you here actually too. But I'm a level 2 certified rope access technician. I've got 1,000 hours logged on the ropes. Here's a picture. I think that's that same building actually when we dropped down on a deck. It's kind of a small pic, but it's you know, nice view of Mount Hood in the background there. And I think that's the same building there too. Here's one in downtown Portland, like kind of hanging, I think 20 stories in the air with nothing below me, just dangling.
Wow.
There's another one where this balcony up here kind of caused us to not be able to put our feet on the building. So we just dangled the whole way down, and you're kind of spinning and don't like totally have control over which way you're facing, you know? So, but we were just basically doing inspections. You know, everyone would ask us when we were in the elevator with all the ropes, like, oh yeah, you guys cleaning the windows? We'd say, yeah, we're cleaning the windows, you know, but really we were actually just like taking digital camera down. You can see in my hand there, and like inspecting the exterior, and then like writing like condition assessment reports for the building owners saying like, here's the condition of your walls, here's the condition of your roof. Like your roof, you can expect to replace your roof within like a year or two because your roof is really bad, you know, and things like that. Delivering, we get really good at delivering bad news to people, essentially. But here's the, you know, building downtown Portland. It's got the windmills on top of it. That was a nice shot there. And that's that same pic that's in the slideshow. But yeah, you get the point. And there's the last one. Good shot of me back in my heyday. See, my feet are on this aluminum panel here. That aluminum panel is actually 1/8 inch thick. It's curved at the edge of this building. It's probably like 5 feet wide and 17 feet tall. So you can imagine a piece of aluminum is pretty big and heavy. And when you're standing on the ground, it doesn't look that crazy. It's just like another panel way up there. But there was actually a windstorm in Portland that ripped one of these corner panels off of the top of the building, and it flew off and like went down like a piece of paper, you know, flying back and forth. And actually, I don't think you can see the building in this photo, but there was an adjacent building that around the 3rd floor, it slammed into the building. And apparently there was someone like in that room that saw the metal panel like coming at them and ducked and like went under a desk or something. And the thing hit, it didn't go into the building, but like glass shattered all the way inside the building and stuff. And, you know, luckily no one was hurt. But at that time, the company I was with got hired to basically do a forensic investigation and like figure out why the panel came off the building, why it failed. My boss at the time who was a licensed structural engineer, did a bunch of structural calculations, but I was in charge of all the field work and had to do all the field verification of like, you know, getting on the building. Basically, there's me taking photos of it right there. And we had to go up in the backside of the panel, which was a crazy story because it was an attic, a 17-foot tall attic above the top of like a high profile lawyer's office. And we had to go in on Saturday, and I won't get into it, but you know, that's the beginning of my career. And then in 2017, I switched jobs. I went from one firm that was named with 3 letters to a different firm that was named with 3 letters. And basically became like, went from junior engineer to senior project manager overnight, and kind of took over a small engineering office for a company based out of Seattle, where I took over all the Portland operations and like grew the business essentially. So I kind of taught myself marketing and business development and tried some things. Some things worked. You know, I'm here 6 years later, and like at first it was just me in Portland, and we had like 5 projects or so, and now I'm about 6 years in, and we have like 30 some projects in Portland, and we have 3 employees in Portland. So happy to report things worked and the business is going really well. And I've learned so much about what to advise people on, you know, and that's why I'm like really kind of excited to share my knowledge, because there's so much to learn. Like, and Scott threw a lot at you there in the beginning. There's a lot of there's a lot of concepts there. Like that in that bullet list he put up, like we could talk for hours about every bullet point, you know. And it's not like that's not valuable, but again, I'm just going to try to like stick to some things that I think can really help you. And what I really want to talk about today is ventilation, which is like maybe a little crazy to hear the envelope guy say like, let's talk about an HVAC concept, because really ventilation falls under the purview of like the mechanical designer and whoever's designing like your heating system essentially, right? But I think it's more important and more simple than that, honestly. I break it down to what is the simplest way to look at a building? You know, what is the function of a building at all? And generally, it's to separate the indoor environment from the outdoor environment. You know, on the most basic level, humans need shelter, and we build a building to shelter ourselves from the exterior, right? And then you think about the purpose of the building envelope, which is, when I say building envelope, I'm referring to the enclosure of the building, the skin of the building, basically any element or wall or roof or below grade wall in the building that separates inside from outside. So exterior walls, right? That's what makes the building basically. That's what separates inside from outside. But I feel like what gets often missed or not, just not given the amount of thought it should be, is ventilation. Because when you think about it, like if you ever walked into a space that's not well ventilated and has had a bunch of people in there, you probably know what I'm talking about. You know, this became apparent to me when I was in a studio. You know, I'm also a musician too, in case you haven't seen all the guitars and drums behind me and whatnot. But my band was recording in a studio that was a basement boiler room, essentially. It was an old boiler room that had been converted into a studio. And there was no outdoor air, fresh air ventilation into this room at all. And we'd go in there and we would like play drums and track songs, and there'd be four of us plus the engineer, so five people in there. Then you go to the bathroom, you come back into the room, you're like, ooh, God, kind of smells like five dudes have been in here for like an hour and a half. You know, not ideal. And that's why I think this is like, it's such a normal human thing. Like any occupant can walk into a room, and if it's not comfortable in there, they're going to want to get out. So like if you haven't designed ventilation into your building correctly, you've failed, no matter how great your building is or how natural your building is, you know. And when we look at ventilation, like when a commercial designer looks at like a big building and designs ventilation, there's actually like every different aspect of engineering has their own like professional organization, you know, like as and the when you're designing like a mechanical system, we have the American Society of Heating and Air Conditioning Engineers, also known as ASHRAE, and they write standards together that say like this standard is a document that outlines more or less like accepted best practice on how to design buildings. And there's a ventilation standard. It's ASHRAE 60 dot something. I can't remember exactly the number, but when you're designing ventilation, you're essentially looking at A, like what is contaminating the environment, and B, like how much outdoor air are we sending into the building to like push all of the air and contamination out of the building, in its simplest form, right? So contamination isn't always like necessarily toxic materials. Like when we talked about the VOCs, the volatile organic compounds, like I tend to picture like, you know, foam insulation and like plastic and things that like might be emitting like toxic things. But let's be real here, that like if you build a building out of clay and dirt and then you seal it off and you don't have any ventilation, you're going to walk in there. What's it going to smell like? It's going to smell like dirt and clay and like mustiness, you know? So like, even if you're using natural materials, like you still need ventilation to push air out of the building. And I just, I see it so commonly, not even with the buildings I'm working in. Actually, the buildings I like work in, a lot of them, when you're in higher, like bigger, bigger buildings, they start to have more sophisticated HVAC systems, which actually may introduce outdoor air. But think about your typical single family house. And like, this is what I talk to most people about, and most friends and family and everyone, because most people have homes, and, you know, most of them don't actually introduce outdoor air through the mechanical system. Like your typical furnace in a building, in a house, just like you've probably seen it. There's probably like a big air intake vent somewhere in the house where the air gets sucked into the heating system. And then maybe ductwork that like takes that air, heats it, and then sends it back into the room, into the house. So you're not actually introducing any outdoor air with that system. You're just taking air that's like in the house and regurgitating it back into the environment after it's been heated. And essentially, like most of these houses worked traditionally because the building envelope leaked air from the outside to the inside. So your outdoor air ventilation actually came through leaky building envelope and leaky single pane windows, essentially, you know? And this is why you hear about people saying, like, they say it all the time on job sites. I think I heard it just last week. Someone was talking about saying, you don't want to be too airtight because then you like cause all these problems. Well, not necessarily, right? You can be airtight, and you just have to provide control to ventilation, right? They say build tight, ventilate right. It's a good rhyme to remember it, you know? Um, so yeah, it's just something I really like want to encourage you guys to think about with these buildings is ventilation. And it doesn't have to be like complex. You know, my house right here, I'm sitting, I actually struggle a little bit because I'm in that exact situation I told you about. Like my furnace pulls air from the inside and sends it straight back to the inside. The only way I can like maintain freshness in my house is to keep windows cracked. You know, that's it. I don't really, unless I like build a vent in, which I've actually been thinking about doing. There are like little vents that you can like that penetrate through the wall that just straight up send outdoor air into your environment, you know? And that, I think that would be, if you don't have like a sophisticated heating system that actually pulls outdoor air into the environment, I think that's a great option. You know, they also make windows that have, they call them little trickle vents in there. So if you've ever seen like a, maybe like a vinyl window or something, and then there's like a little thing that slides at the top of the window and it like opens up some air vents so that air can just like flow in. I honestly, I would think that would be amazing if I had that. I would probably open all of them and then I would be able to close and lock my windows, which is a really nice feature, can, you know, depending on who's camping in the woods over there, that you don't want necessarily like coming over and just being able to open a window and get in your house, you know? So when I leave town, I close and lock all my windows. I come back a week later, my house is stagnant. It is stale. It is like not nice to walk into the house after it's been like that. And I, first thing I do is go and like open windows and like put a fan in the window and blow fresh air in to get it back to homeostasis, and then crack the windows to where they normally are, you know? So it's just like that. That's why I wanted to talk to you about it today, because like I see this in so many buildings. Like we're all going to run into this at some point, and it's not always really like thought about in that way. Like how are we using outdoor air to push like the air out of the environment inside? And that's like, it's one of the simplest human comforts there is, you know? So um, generally when you build your roof, you know, your roof is basically, we build it like impermeable. And when I say impermeable, I mean impermeable to moisture. So we're not talking there's like liquid water that comes from rain. We're talking actually about water vapor. So like gas, water that's in its gaseous state, that's like just suspended in the air, like moisture in the air can diffuse straight through materials that are actually waterproof. Like liquid water will run off certain types of membranes, but the vapor in the water, in the air, the water vapor can diffuse like straight through those membranes. And generally we keep like roofs impermeable, right? That's why you see things like plastic roofing membranes or asphalt roofing membranes. Not that those are the best materials, or definitely far from the most natural. But you know, we typically keep roofs impermeable and walls permeable so that like vapor and just like toxins and anything in the air can permeate and exit the building wall. So it's not trapped. Like ventilation is good. You want to keep it ventilated, keep the air moving out, but it is also a good practice to not like have walls that can trap materials in there so they can't escape. And I think Scott's got some really good speakers for you, you know, coming up. Especially the next person who's, I think, going to be talking on about somewhat similar things, you know, and keeping buildings healthy and like allowing them to breathe. So that's like part of the reason I wanted to kind of set the stage with this idea too. And so really now I want to hear from you guys, like what, when I talk about ventilation like this, what resonates with you, and like what experiences have you run into with this, and maybe even like what's going on in the building that you're like living in right now, or the one you're like sitting in or next to. Like what comes up for you guys when I talk about this concept?
Well, I just want to say, you know, having mostly lived in standard conventional homes, that I totally resonate with what you said, and it's absolutely true. You know, either the buildings will leak a little bit of air because they have little leaks, and or they'll end up being kind of musty unless you open a door or a window, and that can be pretty problematic. I mean, if it's really cold out in the winter, depending on where you live, you know, it could be really cold, and it's like, well, you don't really want to open the door or the window, so you're kind of forced between either letting a bunch of really cold air in, which you kind of need to do once a day, or you know, having pretty poor indoor air quality. So I resonate with that. But I have seen a lot of, you know, seen and built a lot of natural buildings, and I would say that although you can make it airtight if you are using a highly absorptive like natural plaster, like earth plaster or just an earthen wall, the clay materials are, they're hydrophilic, so they're sucking water out of the air, and I think there's something about that effect that sort of cleans the air a little bit. So even if you shut a building up really tight and had earthen plasters, it doesn't get as musty as most other buildings if they have, you know, latex paint, let's say, which is a lot less permeable. It's basically not permeable. Um, and so there's something special about the clays, or even some other masonry like lime, um, where it's essentially kind of treating the air a little bit. So there's that effect. I think it's important to note that you know, the surface or the material that's touching the air does affect the air.
Totally. How about Dawn? Looks like what's your building there? Is that an Airstream?
Um, it's a little Ford Transit Connect.
Nice.
It's my office for the day.
Nice. I love those little vents.
Yeah. And it does have a fan. So,
There you go. Ventilation.
um, but I was thinking when you mentioned the floor registers, because that is in like all of our older 100-year-old homes.
Mhm.
In our house in particular, it just goes to the unfinished basement, to the furnace. And in the summer, sometimes it turns on, but it's just recirculating air. And when I feel it come on, it just smells like the basement. It just smells like a musty dirt basement. And I wonder, I think like, oh, like I've seen tunnels where you can use the earth to naturally cool the house by bringing pipes underneath. But how do you keep it from not being that like musty basement dirt smell? Because it doesn't seem like it's good for that to be coming into the house.
No, that's a great question and great concern. So when you say floor register, it sounds like the air is coming out of the vent in the floor and into the house, basically. Is that what you're talking about?
It like goes through the big floor register and then comes back through the tiny vents.
Yeah. And the big one is in the floor of the first floor, like the main house.
Yeah.
So that's the intake. That's where it's pulling the air from.
Hmm.
So a few things could be happening for sure. Like whatever ductwork goes from where it pulls from the floor down into the system could be leaking, could be extremely leaky, especially like the connection of the duct to the register on the bottom of the floor. Like the register probably sits on the floor and sticks through the floor maybe a little bit. And then there's probably a duct that like catches that. And if those aren't sealed right, like most of like basically if that duct is extremely leaky, it might mostly be pulling air from the basement instead of actually from the first floor. So
Hmm.
that would be my first thought about why would stale basement air be coming out of the vents and going into the house would be like, well, probably because the system's actually pulling air from the basement, um, which is a really solid concern. Like I have allergies myself, and it's been a lifelong journey to say the least. But I know in Portland, like Portland has a lot of wet basements, we call them, which like they're old foundations, they weren't waterproofed back in the day, and there's just a lot of vapor and water, sometimes physical water that actually goes through people's basements. And I can't really hang out in those basements at all. I tried. We used to have band practice in those basements, and then I would wake up at like 4 in the morning and I'd be short of breath and I would have this like itchiness inside. And actually, my house is in a floodplain, one of the most known floodplains in Portland. In 2015, there was a flood that like the basement filled. I didn't live here at that time, but the basement filled with water all the way up to 6 inches from the rafters. There's like a full height basement down there. And it turned into a swimming pool. There was one sump pump which was not functioning correctly. I don't think it turned on. Now there's two sump pumps, and the first one has a like real brand new sensor on it and stuff. So kind of got that dialed in. But needless to say, it's a wet basement. Like when it is raining, water, there's a sump pump, it kicks on. You can hear it kick on to expel the moisture. You can go down there and see water physically bubbling up through the slab and then running across the floor and going over the sump pump. I found a salamander one living down there one time, actually. But I'm pretty sure the salamander probably crawled through the tube that's like expelling the water and went down into the sump pump.
Hmm.
Um, but I don't go down in that basement ever because of my allergy. I don't store anything down there because of the floodplain. It's actually kind of a funky, weird scene down there. Someone went down there at some point as they painted like a um, murals on the wall. There's like a whole beach scene of this person with a trident, like fishing and stuff, and like people dwelled down there. And it makes me wonder, like, was this like that then? And people actually hung out down there? Like that's intense. There's a fireplace down there and stuff. Like it's just unfinished basement. But I don't mess around with that air. There were some vents that were floor registers that had no ductwork on the bottom, so they were like allowing basement air to just come into the house. And that was the first thing I did when I moved in, is I put packing tape over those things and closed them so that air wasn't flowing, and the basement air stayed in the basement essentially. Um, and I can say it's been successful. Like I don't really have allergies in my house, barely at all. Just sometimes when allergens are bad. But I know if I go down to my basement and spend like any amount of time, I'm gonna be short of breath later. So I would definitely recommend like checking that ductwork, and trying to seal it off. Maybe like I think there's things you can do to the duct to like air seal them, like tapes and stuff you can get to seal all the joints. and then especially sealing the duct at the end into that register somehow so that you're 100% sure that all the air being pulled is coming from the first floor. And then again, like you have to look at, is the air on the first floor fresh? Like, are the windows cracked and we actually have like fresh air where it's being pulled in? So I just talked way longer than I actually planned to. So how about Mikey? What's going on in your attic there?
Well, the house is 120 years old, and we used to have a working AC for the dining area because it's a restaurant too. But that stopped working years ago, so we have window units. But basically, you kind of have to tune yourself in with the seasons, and it's all the houses in Portland were never built airtight. You know, they never anticipated climate change, so it never really used to get as hot as it gets now. No triple digit temperature. So and I have fans in the skylight, so they blow in at night, and then I turn them, or I switch the direction to blow out during the day, and then I go down below deck, and I open up all the windows at night and close them in the morning on hot days. So I constantly have to like be mindful of that, just like going through and weatherizing the house, because there you have to, there's like really not good insulation in it. We're talking about making improvements, but it's kind of cost prohibitive, you know, but you just have to do what you want to do. And that's another thing that why I want to live in a natural home, because I just want to have a comfortable temperature. I just want it to be like 68 degrees all the time. I don't want us to break out in a sweat, and I don't want to freeze. So that's my main driver for doing this. I just want to feel comfortable.
Yeah, that makes sense. I'll be honest, you're in a tough situation there. Like in an old Portland home, 3rd floor attic, like there is essentially no amount of upgrades you could do that's going to make it like you're 68 degrees, like awesomely comfortable there all year, unless you basically put like a powerful air conditioner in there and just run it whenever it's like a lot, basically. If you're on the first floor, there's you said it, that's the Portland air conditioning right there, is like you don't really need an air conditioner, you just have to like open and close your windows at the right time, right?
Yeah, batten down the hatches.
Yeah, in the morning when it's hot out, I do the same thing here. Like I go around my house, I close like all the windows in the morning, not all the way again, because I got to keep the ventilation. I keep a few of them cracked, but if it's really hot, the cracks get way smaller for sure. And then let the warmth of the day go by. And if your house is insulated and pretty well airtight, which mine luckily is, because I know the guy who sold it to me, who lived here before, and he went through and like spray foamed and air sealed a bunch of stuff. He also, like when he re-roofed, he put like 4 inches of ridge insulation above the roof deck, so the roof is insulated really well. And I can say with confidence, like my house stays pretty cool when you manage it that way in the summer, even when it's in the hundreds. I have like one air conditioning unit that I keep in my living room, and I almost didn't take it out at all this year. I went on a 2-week trip in the beginning of August, and when I came back, it was like the first day I was back, it was 107 degrees, and I was like, okay, I'm gonna pull my air conditioner out just for a day or two to get through this 100-degree heat wave. But I would say just like don't underestimate the power of like opening the windows at night, letting the cool air run in. Especially in the climate here in the Northwest, that works because it goes down into the 50s and 60s at night, even when it's like 90s and 100 during the day. So yeah, well, who else? I see. Looks like Rain's in a building, Matthew's in a building, like Maria's might be in a building. I don't know. She's got the digital background there.
I'm in an old farmhouse.
Yeah, how's that work out for you?
It's creaky. Part of the house, I think the original foundation was like from 1840 or 1860 or something like that. And the newest part, the kitchen that they redid was like in 2013. So there's a little bit from nearly every decade in this house. And I'm in upstate New York, so my questions or issues are about, I've got 4 extreme seasons here. We've had some weekends where it was below 0 for a couple days in a row, in the teens for like a week. And we've had a cool summer here. It hit 89 for a couple days, but I've seen some hundreds over the history of here. So we've got a pretty, extreme spread and no shortage of rain either. So, moisture, ice, snow, freezing temperatures, hotness. And we can't depend on it getting cold at night as well. So I'm curious how, so much of the structures I've seen where people are building a earthen house in India or Africa, and this building keeps everything nice and cool when it's hot. I'm like, okay, great. What about when it's 0 degrees? How does that handle? So that would be my thoughts about the constant ventilation. We definitely in the winter have to seal everything because just a little breeze coming through, a little nothing will, drop a room 10 degrees pretty easily.
Yeah, totally. That's a challenging climate actually,
Yeah.
because you have to do all the same things we have to do out here that are like cold climate building things, like insulate well and prepare for ice and snow and all that. Maybe even a little more extreme because of snow load and whatnot. But you also have to think about cooling in the summer
Yeah.
potentially. You don't
Yeah.
that Portland style of managing your like opening your windows in the morning and evening doesn't
Yeah.
exactly work over there where it's like over 70 and humid at night. It's like not exactly super comfortable to blow that humid air into your house and then try to sleep with like no covers or one sheet and like be sweating at night. Like
Yeah.
I know all about that from growing up in Maryland and Pennsylvania.
Yeah, laying on top of your bed, just feeling the sweat run down your head.
Yeah, you start thinking about swamp coolers and things like that.
Yeah.
But yeah, I mean, the design of the building envelope is essentially like it's very similar to the way we do it out here. There's just maybe some extra considerations if you're going to be cooling to make sure you're not like avoiding. I think of it because I live here as like the reverse condensation effect, essentially. Like in the cold climate, we keep like our vapor impermeable layers like, on the warm side of the insulation so that you don't end up getting condensation in the wall. Because condensation occurs when you have cold surface in a warm, moist environment. I always think about like a soda can. It's not a soda
Yeah.
can. A soda can gets cold and gets condensation on the outside. In a building, the materials near the outside of the building get cold. And especially materials like if you have a parapet, which is like a roof feature where there's like a wall that just sticks up above the rest of the roof. So it doesn't have conditioned air on either side of it. So that parapet has on a 20-degree day, 20-degree Fahrenheit, you have 20-degree Fahrenheit temperature on all three sides. So that framing in there is probably near 20 degrees Fahrenheit, which is extremely cold. And if you send if conditioned air from your building, 68, 70-degree Fahrenheit air can get up to that extremely cold framing or cold materials, you can get condensation and like mold and decay and failure essentially. In cooling climate, you have to think about it the other direction. Like it's hot, warm outside, and then you're making it cold inside. So the materials on the inside face of your walls are the ones that you have to like look out for that you're not getting condensation. I would say in upstate New York, you're definitely a little bit better off than you would be if you were in Florida. Florida, they really have to like take extreme care to make sure they're not getting like the reverse vapor drive from air conditioning and condensation. But up there, yeah, I mean, I kind of hate to say it, but like cooling kind of is the way to go. From an energy saving standpoint, like cooling is actually one of our biggest uses of energy in the country, actually, maybe even more so than heating. But sometimes it's not quite a way around it, but you can still build efficiently so that, like I said, if you build your envelope tight, airtight, and then ventilate your space correctly, and use like maybe a high efficiency heat pump, because I can't stress enough like how much more efficient like a high efficiency heat pump actually is than just using like heaters, like space heaters or even like hydronic like steam heaters or a non-high efficiency heat pump. Basically like a furnace is about 80% efficiency, which is actually pretty good when you think about it. It means like, and when I say 80% efficiency, I mean like you put fuel and energy into this machine and it converts like 80% of that embodied energy into like actually cooling your environment or heating your environment, and the other 20% is spent like running the machine and like exhausted to the exterior and whatnot. Whereas like a high efficiency furnace is more like in the 90 some range, like 95% versus like 80. So it's actually like that's extremely efficient in the grand scheme of processes. When you look at like an internal combustion engine car, like all the embodied energy that goes in with the gasoline and like the actual efficiency, like the amount of that energy we're using to like move the car and heat the car and do everything the car does, it's around like 17% or something ridiculously low, so we have some leaps and bounds to make there for sure. What about you, Maria? What's going on with you?
Well, I'm in a property, a building, a mixed use that I have for so many years, and I start notice the mold between some of the walls, right? So I've been, one of my reasons, what you explain now about the ventilation and all the stuff, I usually open all the windows. Like, I don't care if it's cold, hot, I need air, like they need to run the air because it's always been stuffy. And this building is being like, I don't go home because it's one of my rentals, but anyway, it's 130 something years old. So it's very old. And the wall that I start notice that is, it was rebuilt like 10 years ago. And I start seeing more, oh my God, what is going on here? Because it's not good. I know it's not good. So, and I've always been interested on organic materials. And yeah, I want to build a home that is completely organic, like earth materials for me and for sale, because I'm I agent. So that's what I do, build houses, but I don't want to use more toxic materials. I mean, insulation is toxic. All the materials that we use, they're toxic. Everything right now, I mean.
A lot of them are, that's for sure. And even some that like aren't as toxic. Like when you look at insulation, like fiberglass has all kinds of stuff in it, you know.
Yeah.
Foam board is generally like they take a blowing agent chemical and send it through, you know, a petroleum product. I call those toxic. Then there's like rock wool, you know, mineral wool, which is made from stones, which like I wouldn't call that very toxic. It's inorganic. It's like sand, stone, and stuff, but it also takes like a lot of energy to make rock wool. Like they have to basically crush rocks, which takes like, you know, the clinker machine and all kinds of crazy processes. So there's always an impact. But you're right. Like, how can we avoid toxic materials? And I actually enjoy like really digging into materials and learning like what are materials? What makes it toxic? You know, I was fascinated to learn a few years ago when I was reviewing a PVC roofing submittal, which PVC roofing is like a white plastic sheet that comes in like a 10-foot wide roll, and like they roll it out on the roof and weld the seams with hot air, like literally blow hot air at the plastic, and so it fuses together. It's a good roofing system. It's, you know, but what I was really fascinated to learn was that the main ingredients in PVC, which was really surprising to me. I won't make you guess, but there's two. One is natural gas. The second one is salt. It's actually plastic, like polyvinyl chloride. Vinyl, PVC, is mostly natural gas and salt, which, like, let's break that down. Like salt, we can harvest that from the ocean. You know, you can take water and like dry it out and get salt. Like it's not super toxic. And then there's natural gas. Like, yes, fracking, especially coming from Pennsylvania, not into fracking, you know, not into Halliburton and like natural gas companies. But natural gas can be made in other ways that aren't fracking. Like I was saying earlier, I was involved in a project in college where we made anaerobic digesters. So you can literally take we could take wastewater, like theoretically, in my mind, I believe we could take wastewater, like black water, which is actually, in some people's opinion, our biggest misused resource. Like we take black water and like treat it and do all this shit and then send it and just dump it basically, you know, but we could be like taking that black water and like harvesting natural gas off of it. And we could potentially like power things that use natural gas instead of fracking and sending natural gas along pipelines halfway across the country and destroying our environment. We could be taking the waste and like turning it into natural gas and maybe even combining that with salt and making like vinyl and like plastic, polyvinyl chloride, that's made from natural materials. Like there's a lot to unpack there, and I don't know all the specifics, but like I really just encourage you to think critically about what is toxic and what's not toxic, you know, what can be done differently, you know. But I admire where you're coming from and wanting to build buildings organically and without these toxic materials. You know, it takes actually a lot of bravery and courage in a world like this to stand up and put your foot down And especially because when rubber hits the road and you start doing this, you get like pushback from a lot of people like, oh, that's crazy, that's too expensive.
Yeah.
You know, what you go
Sure.
back and play your drum in the dirt with these ideas, you know, like and it's almost the same with the food system. Like our food system is crazy and needs a revolution. And as soon as you start trying to eat real food and get food that doesn't have like poison in it, and people are like, oh, what are you on, some kind of diet? And you deal with like all this crazy like pushback from people, and it costs more. And it honestly, it takes a lot of courage, and I said that one already, but perseverance and dedication. And I admire that out of you guys. So, you know, you can feel free to give yourself a pat on the back for just showing up today to like learn more about bioarchitecture and continue on this journey, because I think you're on the right path.
I got a 1978 travel trailer. It was a park model, and I gutted it all out and rebuilt it with whatever materials I could find. And I heat with a wood stove. I cook with the wood stove. I have tiny little solar panels that I use for lighting, and a generator, the jump pack one that you use for your car when I need to plug things in, like my phone right now. And I use rock wool on most of the insulation. Some is fiberglass because it was donated to me. And I just open windows, close windows, you know, do the same with the door. I have curtains and just different ways to block the sun or let the sun in. And everything was pretty sound until we had flooding, and I didn't think I was affected at all. But then like 4 or 5 days ago, I started to smell mustiness. And now no water got into the building, but there was enough moisture underneath that it seeped up in. So I've, you know, trying to take care of that now.
Yeah, that can be tricky because sometimes once it gets in there, it doesn't want to get out. And like, unfortunately, sometimes the only way is to like pull materials out so they can dry out and put them back in. Like, I don't want to say you have to rip your floor out, but like if you really are fighting it, it might be a good idea, you know?
Yeah, fortunately it's unfinished, so the, you know, it won't be a big deal. There's like 4 squares of carpet on the floor. So, and I just have to seal up. I have a sliding glass door and have to seal that up. I think some of it is right along there because
Nice.
I had some fungi growing. And I was like, oh no.
I've also
you
had
don't.
I've had some good luck using dehumidifiers. It depends how sealed your floor or your wall is, but if there's any cracks or if you're dealing with something that's made of wood, if you just make the air super dry, it will take a long time, but it can pull moisture out of the surface wood, and then that wood will slowly pull the moisture out of the other wood. It sort of depends. I mean, if you have moisture locked in your cavities in there, you might need to open it, but you can sometimes pull it out with a dehumidifier.
The good news
Yeah,
about
and
trailer,
I'm actually using dehumidifiers at my mom's house because she got a lot of water in her. So.
just to say, the good thing about your trailer is like there's an airspace underneath of it, and you can like push air under that space and like get down there and see what's going on. Whereas like, you know, a set in place building, it's not always that simple. You know, Scott and I have a mutual friend in Hawaii, and there was like some big rains. He's just renting a place from somebody, and I don't know who built it, but like it appears that moisture from the ground can just like go right, can kind of like seep right through and drive into the framing essentially at the bottom of the stairs. And it was all good until like all of a sudden it got like real wet there. And then, yeah, literally like mushrooms, like a lot of mushrooms, not a little bit. He sent me photos like, boom, like looked like a colony, you know, we're growing there. And it's funny because he's a building envelope consultant too. Like he does the same line of work. He and Scott actually used to work together, you know?
Well, the thing is, you take care of other people before yourself when you do so. That's like the mechanic that never has a working car, you know?
Yeah. Yeah, there's what we recommend as consultants and then what goes on at our own house. You know, like I say, outdoor air is great, but my house doesn't have any of it. I have to crack all my windows, you know? But yeah, There's one last thing that I want to think of here, which is when we were talking about ventilation, I was saying how you can like install vents that basically just take outdoor air and send it straight into your building, which is great. But also a little bit like when you're thinking about the winter time, you're kind of like, maybe I don't want like extremely cold air going straight into my building. And same about the summer when it's blazing hot and humid. Like, I'm not sure I want that air just like flowing right in. And I would venture a guess that Scott's gonna have other speakers that might even talk more about this, but you might have heard of the term like an ERV, which is like an energy recovery ventilator, which sounds complicated, but really what it is like imagine you have that hole in the side of in your wall that like lets outdoor air in, right? Instead of it just coming straight into the building as like extremely cold air, you basically like duct it to this like you have the ductworks that like cross each other, essentially, or ductworks that are next to each other, so that like heat can transfer through the duct. This is I'm very much simplifying it, but you can literally go and buy these ERV units that all this is like takes place inside the unit. You just hook it up and like install it. But essentially what it does is it takes outdoor air, runs it past like air that's like you have a ductwork that's pulling air from the room, and you're basically using the heat that's in the room to preheat that outdoor air before it goes into your space. So the air ends up coming out of the space. Yeah, pretty much exactly like this. The outdoor air comes into your space, not at like 20 degrees Fahrenheit. It comes into your space maybe more like 55 or 60 degrees Fahrenheit. So that you're not like your heating system then doesn't have to do as much work to and that's an understatement. Your heating system doesn't have to do barely anywhere near as much work to like deal with the cold air that's coming in, because you've used the warmth and the energy that's already in the room. And those things are like, they're amazing. Like I kind of want to install one here, because I literally think you can go buy these units. And I was talking with the guy who runs our energy department at my company. We have like different departments, and energy savings is one of them. And the guy who runs that, I think, was telling me he installed one in his house, and his power bills went down like ridiculously after he put this ERV in. So definitely worth looking into for sure.
Yeah, I was just looking up these devices recently online, and they have, obviously different levels of fancy and, durability, but the cheapest ones are not that bad. I mean, you can get a small one, it's like $800. And, that could maybe service a small building or a couple of rooms. And it's a pretty great idea. It definitely one of the best things about the techie solutions that we have available.
Yeah, and $800, like how long does that, if that reduces your power bill, how long does that actually take to pay off? Like it's not even very much. Power bills on a regular house can be as much as a couple hundred per month. So even if you're shaving like $30 or 50, call it $50 off your heating bill, that means it takes what, 16 months to pay off, like a year or two. That's nothing when you're looking at the grand scheme of a building. When you're designing like energy improving devices into like a large commercial building, that's how you study it. It's like, is this worth doing? Is it going to reduce the power bill enough that like it makes sense to spend the extra money to invest in this? And when you're looking at a building, typically anything less than 30 years for a payoff is like worth doing, because you're planning your building to be there more than 30 years. Mechanical systems, they get replaced maybe sooner, so you might be looking at more like a 15 to 20 year window, but still, I agree, man. For $800, so it's definitely worth looking into.
I totally agree, and I'm part of a few different, chats of folks who are interested in DIY, let's say, a natural building, appropriate technology. And there's been a lot of talk recently in some of these groups about, like a homemade system that would essentially do the same thing. And so, some of these more old school, let's say like a heat recovery ventilation, originally, instead of being a complex radiator system where the different gases move across each other in the box, it's more like a linear tube system. So you would have expelling like interior air going through a smaller tube, and then the exterior air that's coming in would be going in a larger tube that's around the smaller tube, if that makes sense. And you could have a long run of this, and you can pull air, and then that way they're still touching each other for quite a while, and you get some exchange. But I think, clearly the most modern engineered system is probably going to be the most efficient, because you see, when you look at the internal workings of this mechanism, it's really is like a car radiator. So if you can imagine, a series of very tiny fins, so that the hot air is moving across little fins and getting cooled by the cool air that's running the other way in another in another series of channels, just like this. It's like that. A lot of points of contact, maximum contact between the two without them actually touching one another. Pretty interesting.
Yeah, and it can even be as simple as like the vent comes in from through the wall, and then there's a duct that's inside the space here. So like I could look over and see a duct on the inside of the wall, and it goes like around the room and then lets the air directly into the room. Because like the outdoor air is going to go into the duct cold, and then as it travels through the duct, the room is heating the air, so that like when the air comes out, it's no longer like extremely cold. It's just warm. Like it's warmer. It won't be. That's not as efficient as like the heat exchanger and the actual ERV unit, but it's the same concept of just like, hey, let's not waste all this energy that's already here, and let's like use it to like preheat some things so we don't have to heat them as much.
Yeah, definitely. Yeah, and then there are some really effective modern versions of underground tubing. Like, so you draw air in and go down under the ground and go maybe 20 feet under the ground for a while and then come out into your house. So that way, if the air is 20 degrees, if you go down a few feet, the ground is going to be 60 degrees, 55 degrees. So it heats up the air to 55 at least before it comes in. And that's pretty low tech, and it could be done yourself. That's a brilliant idea. And then it's also an important concept to acknowledge that, most all the houses that we're used to and buildings that we go in frequently are generally, they rely on heating the air, which works and it can be comfortable, but it's actually more difficult to heat the air in a building to make it comfortable than it is to, say, just heat the mass of the walls or the mass of the floor. And so and you look at a lot of old school buildings, like 1800s or turn of the century, and they all had these radiators. They all had boilers, and they would circulate water or oil or some kind of liquid through these radiators. And the radiators it's radiant heat energy. So it's a different type of heat, and it's actually a lot easier to achieve comfort using radiant heat. They did a bunch of surveying of people, and there's kind of like, some of it has to do with psychology, which is kind of interesting, but generally, if you're heating the air and you only heat the air down to like 6 feet off the floor, all that air it's wasted because it's above you. You're not even touching it, but your head is hot and your feet are cold, and it's just not comfortable. You don't, you don't feel good. But if it's the opposite, like if your feet are warm and the air is somewhat cool, generally that's considered comfortable. People feel good in that type of environment. And what's also interesting is, I think it was out of Germany. They did some studies with radiant floor heating, because it is comfortable, but they found that it can contribute to problems with like circulation and varicose veins. And so they realized over time that for the health of the people, it was better to have the radiant heating embedded in the wall system. So the lower part of the walls, that's the most modern accepted best practice, is install it in the wall system rather than the floor. But yeah, outstanding. I mean, I absolutely loved this part, your presentation, Tyler, and the sharing and hearing from each person. Outstanding.
Yeah, man. Thanks for having me. Really glad to be a part of this and to meet all you guys, and just kind of be in an inspiring container. That's what fuels my life right now.
Thank you.
Thanks, Tyler.
Thanks, guys. See you.
Tyler.
Thank you, Tyler.
Thanks, Tyler.